right. Yesterday we did the opening topic in solids of revolution. And last night I thought about how many questions I should ask for Friday. I'm going to check tonight when I go into Parkland, but I think I'm going to go with what I have. I think it's close enough to what they already have in there.
You can be able to use our notes.
No.
Pardon the interruption. There may be driver's ed students arriving to your class late this hour. They had a demonstration out in the bus bar. Allow them to enter your class. We're not late for it. Thank you.
All right. So we did pi r squared h for the volume, and we are perpendicular to the x-axis. So there's some things that we're going to talk about today that change that, but if you're perpendicular to the x-axis, it is considered a dx. Perpendicular to the y-axis, it's going to be considered dy. Oh yeah, on Friday, before I forget, I think it's going to be like either 5 or 6 questions, either 5 or 4 points each for 24 or 25 points. It'll be 2 points or 1 point for the picture, 2 points for the integral, and 1 point for the solution. Okay? And I'll give you plenty of time. 2 points or 1 point for an accurate picture, 2 points for the integral, and 1 point for the solution. Okay? Yeah. Correct. Okay? So, with that said, huh? Nope. No, you don't have to, but you should. All right, questions on any of the homework? Any questions on any of the homework? We did what, 1 through 15 odd or something? 19? Yeah.
It's not like a specific question, but when you plug it into the integral and you get the decimal, how do you know? Like, on number 13, it has a square root in it.
Oh, you can't do that with the calculator. You have to do that manually. So on Friday, I think everything's set up for the calculator. All the fractions will come out. So if your answer, well, you remember that one yesterday we had 0.400000358. We went with 0.4 to get to 2/5. So we made that adjustment in our answer. So it's all going to be like that.
On 13, they make it so you multiply it by 2 and back to both. Why can't we just make the
Yeah, they use the fact that they're both even functions. They went symmetric around the y-axis.
all right, so we could just make it go Friday.
Right, but the reason that's kind of important is if I take the x squared and if I take the 4 minus x squared, and if I go around the x-axis, one thing you have to be careful of, so you set up as a dx integral, right? And what are the bounds, 0 to 2? Or negative 2 to 2? Okay. So negative square root of 2 to square root of 2. And so it's x squared all squared minus, oh yeah, 4 minus x squared. No, because when you combine like terms, you have 2x squared equals 4. 4 equals 2x squared, so you divide by 2, so x equals plus or minus root 2 when you set them equal. 4 minus x squared, squared. All right. One thing about this problem is if you're going around the dx integral, what he said was in the back they just took it from 0 to 2 and doubled it. That's using the symmetry, and that's fine. You can do it either way. But if you take this around the y-axis, you can only use half of it. If you use the whole thing and go 360, imagine this side being like a red solid coming around, and this on the other side being like a green solid going around also. The green solid will actually take out all the red solid volume, so you get 0 as your answer. So if you have a problem like this going around the y-axis, you know that you can only use half of it. So the fact that it's going on the x-axis, yes, you can double it. If it were going around the y-axis, you wouldn't double it. You would just leave it as is, only use half of the region. because one would trace out the other one, because one's a positive volume and one's a negative volume. So you have to be careful with that.
So what if it's like not symmetrical?
Then you have to worry about it. Okay? It's the symmetrical ones, depending on which axis you're symmetrical around, depends on how you set it up. You can either double it, or you're only going to use half in your calculations. Okay? Thank you. Anything else for the homework? Yeah? Hand that to Warren, please. Which one? 17, sure. 17. X equals y squared. I'm guessing would look something like this. Let's see, if x were 3, y would be 9, or negative 9, or square root of 3, negative square root of 3. And then something like this. Like that. Is that close to the picture?
Picture exactly.
Oh, great. Now we're going around the y-axis. So we went for the positive radius. Set them equal to each other. Y squared equals 2y. I just had this talk last hour with my trig class. Don't divide and lose variables. Instead, subtract and factor. So you have y squared minus 2y equals 0. Y times y minus 2 equals 0. Y equals 0 and 2. So 2 is going to be right here, and 0 is going to be right here. Those are the bounds of the integral. So I can take pi from 0 to 2 of 2y squared dy minus pi 0 to 2. I mean, you can combine them. I'm writing them separately right now. Y squared squared dy. And obviously you can combine it as one integral. Pi from 0 to 2. I don't know, I'll just write it like this. 4y squared minus y to the 4th dy. And somebody asked me the other day how to type this in. For something not that difficult, I would type it in just like that on the home screen. You know, if you want to mess with the y1s and y2s, that's fine. But if you graph that in parametric mode, you can't use y1s and y2s. So that kind of prevents you from doing that. So that one I would just type out. Function integrate, 4x squared minus x to the 4th, comma x, comma 0, comma 2. Close it off. Okay? Questions? All right, today's going to get a little bit more fun. I want to go over one that somebody asked me. Which one was that, Kayla? Number 7? Okay. Number 7, I want to go over for one very important reason. I think it just kind of got blown over. And I kind of need it for today. If I did x squared minus 4x, that means y equals x, x minus 4, and y equals 0. Go around the x-axis. Okay? Anybody notice a problem with this one, just out of curiosity? Good. It's what? Okay. Well, I don't know. I'll go through it anyway. 0 and 4. 0 and 4. Y equals 0 is the x-axis, and you're going around the x-axis. Okay? Now, when you sketch your picture on Friday, that's part of it, but you're going to be finding the area between two graphs. Don't forget, you're not doing volume Friday, you're doing area. So don't be throwing pi r squareds in there and things like that. I'm going to draw my rectangle, so I know it's a dx integral, and set up my integral. Pi, I know it's a dx integral from 0 to 4. Here comes the interesting part. The radius of this graph is the length of this rectangle. Okay? And I understand that if you square any number, it's going to come out positive. But when I checked the solutions, they said that they put in just the x squared minus 4x all squared. When I did it, I did 0 minus x squared minus 4x. And somebody would say, oh, why'd you do that? In fact, the person said, why'd you do that? I said, well, these are negative y values down here. I like my radius to always be positive. And then I remembered we haven't finished the section today yet on calculating positive radiuses. We just started. So that's going to come into play today. Do you see how 0 minus this gives me a positive radius? Okay. This equation is 0. It's kind of like the old top minus bottom trick to get a positive radius. Okay, that's the only reason I set it up like that, a positive radius. So I'm going to use that kind of as my lead-in example for doing the next types of problems. I always like to set them up with a positive radius so I can square them and get pi and all that other stuff. Okay? Great. So that's the lead-in for today's question because we're moving things off the x-axis, I think. Maybe. We'll see. He agreed. He would agree. No, I'm talking about him. All right. He better get his story straight. Here we go. Sketch the region bounded by the gravity equation. Find the volume of solid. That one looks hard. Let's start here. Yeah, no retreat, no surrender. So we're going around the y-axis. Wes, what's that mean to you if we're going around the y-axis? dy integral. So all our equations should say x equals. Okay? If you're thinking like that, that's pretty good. You're in pretty good shape. So x equals 1 minus y. X equals y minus 1. X equals 2. So those are the three graphs. I want to rotate around the y-axis. The problem with thinking about x equals is you're not used to graphing like that, and you're used to graphing y equals equations. Well, it's 6 one way, half a dozen the other. Here you got for the first one, you've got a y-intercept of 1, a slope of -1, and there's your line. For this next one, you've got a slope-intercept of 1. If I do this one, I'm thinking of this as, if you want, that's fine, I don't care. I don't want to though. So y-intercept of 1, slope of 1, there we go. And then x equals 2 is a vertical line. Right there. So I have the points. This point in blue I know is 0, 1. The point in green I know is 2, -1, isn't it? -1, is that the right point? I think so. And up here, if it's 2, 3, 2, 3. I think so. How's that look so far? All right? Fantastic. Now, as Coy just said, it's right minus left. The problem is I go from green to blue with one of my rectangles, and then I go from green to red with my other rectangle. And I have to go dy because that's the only thing I know right now until next week, until our next section. So this one's going to require 2 integrals. Yeah, and then you add the 2 integrals. So that's what we're going to do. We're going to set it up as 2 integrals. Oh, you want to do the top one first?
Yeah.
Okay. So we'll go from 1 to 2 of 2 squared minus, the blue is Yeah, 1 to 3, thanks. See, if I do that, they'll never know. No, they won't. 1 to 3. Y minus 1 squared dy with a pi in there plus negative 1 to 1. I'm using the y values again. The y values. Negative 1 to 1 of 2 squared minus 1 minus y squared dy. Okay? Yeah, you can use your calculator, that's fine. And then, oh yeah, I need a pi. So, yeah, you can punch down the calculator. Take you 2 separate arguments to do that. You gonna punch it out for me? Oh, great thinker.
Sure.
Great. Your calculator runs by thought? Doubt it. Punch it out, give it a go, see if it works.
Is there a way to simplify that equation in one punch down?
Sure, you can put 4 minus.
I don't know, but I mean, like, because we learned that one thing where it was like,
Oh, that's if the functions were the same.
oh, since they're not the same.
Right, since they're not the same, you can't combine with the bounds. Right. If the functions were the same, you can. So, as we whirl this through, I don't feel like punching it out. I'll wait for the great thinker to do that for me.
Not even a great thinker.
Sure you are. Best we got right now in the front row. Oh, just kidding. Let's go punch it out quick. No one's catching up. Actually, Sydney's almost done.
I got the same thing.
What'd you get? Is it a secret?
I got 16/3 for both of them. I think.
So 32/3 is the overall answer? Okay.
Thank you.
So it's 32 pi over 3. All right. Anyway, take your time, go through it slow, make a good picture, and there's a lot of things to keep track of. But you're getting to that point where your math problems are going to take you a little bit longer each time. Well, yeah, this is the right triangle right here.
Yeah, that's nice. Well, I mean, it's like.
Okay.
Cool.
Kayla and I both
Yeah.
got 6.
I was like, oh, yeah.
6?
Doing something, yeah.
6 what?
For
I don't know. I didn't do it. What was your calculator?
I got 6 and then I got 16.
You forgot to square the 1 minus x.
Oh,
You got to square both of those.
there you go, Kayla.
Okay? She, in her calculator, she didn't have the little squared after y minus 1.
That's a good one. That's a good
Good. All right, we're moving on. Oh, this one. Since we're not doing use substitution, and since we're not integrating by hand, on this one you really don't have to use the half angle formula. That's for an integration by hand, and we'll do that later, later on in the year when we go back to integration. But right now we're doing volume, so we're going from 0 to 2 pi as your window setup. We're going around the x-axis. So that's nice. You don't have to solve for x. If you had to solve for x, you have to use inverse cosines, which we can do, but thankfully we don't do it right now. The main thing is just to get your graph, and I'll do this one with you. But this one's really easy now since we're just doing the graph. Y equals 1 plus cosine 3x from 0 to 2 pi, window 0 to 2 pi. Make sure obviously you are in radians. I don't need -5 to 5. I'll go -2 to 2. Actually, I only need -1 to 1, but that's okay. And then I hit 0 to 2 pi, pi over 2 for my x's. Then my mode, make sure I'm in radians, and hit my graph. Good thing. So, if I'm rotating this around, it's kind of a cool graph if you stop and think about it.
Really cool.
They give you the bounds, 0 to pi. So set it up. 0 to pi, pi, 1 plus cosine 3x squared dx. So I can quit. Math, 9, bars, y bars, function, y1, squared, x, comma 0, comma 2, pi. I don't think it's going to fractionalize. So I'll end up with, I'll multiply it by pi now, since it won't fractionalize, and get 29.6. If you're going to go with a decimal answer, don't put a decimal with pi. Pi is reserved for exact values. So for this one, I put 29.6. You're going to see those options later on, not this week, but next week. Okay. Now we get to the fun part.
I'm excited.
I am too. All right. Oh, geez, I forgot it's homeroom. All right. Sketch the region. This is the region number 26. Sketch the region bounded by the graphs of the equations and find the volume of the solid generated if R is revolved about the given line. So the lines change. This problem is done 4 different ways, but they, of course, they all follow a similar theme. Okay? So I'm going to do, I'll do A, and I'll do C. I'll do one line around X, one line around Y. This is fun. This is like the best part of the whole section. Anyway, Y equals square root of X. From, goes up to 4, stops right there, and 0. So this point is 4, 2. This point is 4, 0. This point, 0, 0, just for the sake of reference.
So it's on the X. The rotating around that X line.
Right. So what? Yeah, so I'm going to take, I'll use this one. Pink, sure. We're going to rotate it around this line right here. Oh, sure. Remember, if I do this, there's my rectangle, which is the radius. This is my radius, and as you said, it's going to be a dy integral. Okay? So I'm doing part A right now, around the line x equals 4. So I'm going to use y values for my integral. So far, so good. The integral will go from 2 to 0. 0 to 2. It's a dy integral because I have to be perpendicular to the axis of rotation. Now, I have to find the length of this to make sure it's positive. So far, so good? Okay, great. This is the line x equals 4, isn't it? So if x equaled 3, how long would my radius be? If x equals 3, and I'm going to 4. It'd be what? 1. So if x equals 3, my radius actually equals 1. If x equals 3.5, what's my radius going to be? A half, right? Well, the problem is, normally our x units start at the origin and go from left to right. But in calculating the radius, we have to start at this line 4 and go to the left. So if I have an x value of 1, the radius would be what? 3. So how can I write that into my equation? What am I doing all the time? I'm taking 4 minus the value, right? So if I take 4 minus y squared, remember if I put in a 1, 2, 3, or 4, and then I square it, that's the radius. If x is 1, y is 1, and the radius is 3. Right? If x is 2, y is 4, and the radius is 0. No. If x is 2, that means y is a square root of 2. Okay, good. We're in good shape. That was close for a minute. All right. Back on track. So we want to make sure this is a positive radius when we do it. Okay? I don't think we, it says then find the volume. Okay, you can find the volume. I think I'll leave that up to you. That's easy to do, isn't it? Okay.
Oh, yeah.
All right, let's take that same picture and generate it around the line y equals 2. Pink line? There you go, blue bar. So now I'm going around this line right here. So it's going to be what kind of integral? Dx. What's wrong? Oh. All right, you ready? Oh, what do you want it to be? Oh, because I did the right minus left? Right minus left to make sure it's positive? Okay. Now on this one, this is going to take you just a little bit of time to adjust. If I were to give you this picture and rotate it around the line y equals 2, a lot of you would think that you're taking this region right here. You're taking this region right here and rotating it around. Okay? Don't forget you're taking that region and rotating it around. That means there's a gap in the problem. You're going to subtract 2 different volumes, like y1 squared minus y2 squared. So, the one that has the most volume, I've used all my colors, I'll use this one, would be from 0, am I doing dx or dy? Dx, right? So I'm going to go from 0 to 4 of the line. What's the radius of that black rectangle? It's always going from blue to green, isn't it? 2. So I have 2 squared dx pi. Okay? I mean, that's how to find the volume of that cylinder. Yeah, then I take minus from 0 to 4 pi And the next one is going to be yeah, later on we will. But how would I get this equation now? I have to subtract the blue to the red. 2 minus square root of x squared dx. That is the length of the radius. If x is 0, the radius is going to be 2. If x is 1, the radius is going to be 1 because y equals 1. Okay? Yeah.
The second one, why do you need the 2 minus?
Because I'm not going around the axis. I'm going around the line y equals 2. So everything is shifted up 2 in my object or in my graph. That didn't work, did it?
It's like the blue line minus the red line.
Yeah, it's like the blue line minus the red line. It's like top minus bottom to make sure it's positive. And I want my radius to be positive. So if you want to put together all in one integral, you can. That'd be, because you can do that, it'd be pi from 0 to 4, 2 squared minus 2 minus square root of x squared dx. Oh, that's going to be fun in a week.
Why does it mean?
No, I mean just that problem.
It's fun right now.
Oh, yeah, it's just going to get better. It is. I think, see, we didn't get a very big push today as far as the problems in the section, but we got a couple of big things covered.
Oh, we did good.
Oh, we're making progress left and right.
Jeez. So,
We're general.
we'll do this one and that. Wait, what time we got here?
12.
12? We'll pick this up tomorrow. So that means we got to do 19 through 25 odd. I did A and C. Well, see, the problem is when they switch to line 6, then that develops a gap. So you're going to have the separation of 2 volumes. And then we do 4. Sure. I'm going to give you a few problems, so go ahead and do them all. Give it a shot. And I'll try to get the solutions up and running. And we'll start this one tomorrow.